YT channel. This is again, I'm a singer in a voice, YouTube content creator. Oh, I'm wearing green. Sarah All. Okay, congratulations to a very successful campaign rally in SRP Cebu, the Uniten BBM Sarah. Oh, I love it. Okay, going back to the topic of forces. So actually guys, there's a lot of forces I discussed yesterday. It's gonna be around 15 to a maximum of 20 forces. But you know, there are really relevant type of forces that we encountered in our daily lives that we use every time. And then we cannot just notice them, but we cannot survive without them. Things like that, especially when we do our tasks and we have energy, because energy always cope up and to be applied with forces, various type of forces. Okay, you cannot do the job without forces involved. Okay, then how can you do the movement, the motion? Okay, then there's no work done at all if this is gonna be the case, right? Get the point. Okay, now let's review I think it's gonna be four basic type of forces. It's gonna be the most relevant forces and the basic type of forces without really, scrutinizing, comprehensively in detailed fashion the different types of forces that runs to about 15 type or to 50 to 20 type of forces. Okay, something like that. So it's gonna be like that. Okay, first thing is, shall I say, major type of forces or the fundamental. I mean, for the fundamental are the same as relevant. Okay, meaning to say the most significant type of forces are relevant. Something. Okay, the same meaning, right? In Webster Dictionary, relevant, significant, like that, or shall we say, essential. Okay, or the most important. Okay, so we're gonna say that it is the most important, okay, or relevant. Okay, relevant, you know, types of forces. Okay, or shall we say the major, okay, major type of forces. Okay, we need to say we don't go to the details. Okay, so relevant or major types of forces. First, we have the nuclear force. Okay, nuclear force, mga palangga. Okay, so nuclear force, it deals with atoms, molecules present in an element or in a compound, and sometimes also it will be intensified if we will be undergoing the chemical reactions, chemical bonding. So these forces are there. Okay, nuclear forces, because it talks about the nucleus from the root word of nuclear. So what's in the nucleus are protons and neutrons, and these protons and neutrons really are the nuclear charges of our elements. And of course, when they're bonded together, they will produce a compound. Then if we try to break each element of that compound, so there are individual nuclear charges. So when they participate during the motion of interaction, could it be a repulsive attraction or attractive forces, then they'll be able to produce nuclear forces. Okay? Something like that. So number two, we have nakakaloka, electric forces. But actually, we need to say electromagnetic forces. Why? I may explain why. Okay? Electromagnetic forces. Because these electric forces is under only two electromagnetic forces. This electromagnetic forces composed of electric forces and magnetic forces. Okay, that's why electromagnetic forces. So Sotero, then why you are not saying electron forces? Okay, electrons are the particles that push or drive to produce an electric forces. That's why we have electricity. If that is the case, we will say electronicity. Why we say electricity? Because it is electric. Okay, we will never say electronicity. It's not existent in Webster dictionary. Okay, it's always electricity from electric force driven by electrons flow or movement in a path, in a wire, or let us say in an object that being considered, or let us say in a, in a molecule, anything, because everything has electrons flow. Different materials around us have electrons flow. Okay, because remember we have a static, yeah, static electricity. So if you have static electricity, we have also electrostatic. Okay, ganon. So it's gonna be like that. So electric forces and magnetic forces, mga palangga kung hitad. It's not electron forces that's wrong chemistry grammar. There's no electron forces. Electric forces, but it is the electrons moving, okay? Transferring, shared, donated, like that, okay? In a particular chemical bond in your electromagnetic forces, okay? Electric forces and magnetic forces, okay? You get the point? Okay. So let's be detailed in the second type. Okay, magnetic forces. Okay, magnetic forces is very clear that you have to have a magnetic field. Okay, like that. Magnetic field. And then your electric forces, you have the electric field. Okay, like that. So these are all electromagnetic forces. That's why I did not put electric forces because that is not the general. Is under electromagnetic forces. And in the topic of chemistry, we need to deal this separately. We have electromagnetism topic in chemistry. So it's there, you need to discuss very detailed. Okay, electromagnetism. Okay, like this. Where in all of their topics it talks about, polarity, like that, electrostatic forces, electric charges, magnetic field, magnetic forces, blah blah blah, so and so. Okay, number 3, we have, what else? Mga palangga umitan. Okay, we have gravitational force. Okay, gravitational force, mga palangga. Okay, so this gravitational force is highly natural. Okay, okay, gravitational force is highly natural. For example, if there's dropping of stone downward or falling left, left, L-E-A-F, dahon. Okay, it has a gravitational force down to the earth. Or every human being has its own gravity directed towards to the earth surface. Okay, so we mean to say that the gravitational force will be just equal to the mass of an object, any kind of object, and then times the acceleration due to gravity. Okay, and the unit will be Newton. So you could say gravitational force is equal to mass times acceleration due to gravity, and then this is also the weight. So basically weight is equal to force, that's why weight is equal to Newton. Okay, weight doesn't necessarily mean a gram or a kilogram or a pound. Okay, but sometimes weight can be pound force. Pound force. The force here indicates that this is a weight. Okay, that's why this kind of weight is a weight force. Okay? Nakakaloka, di ba? Ganon siya. Okay, and if you try to substitute this with the English unit, you're gonna change your 9.81 meter per second squared to 32.2 feet per second squared so that you can be able to attain the pound force, unit of force, right? Yeah. It's gonna be like that. Because your Newton is kilogram meter per second squared, there is a metric system involved, the kilogram and the meter. But English is another story. It needs to involve pound and feet somewhere along the way of the unit, something like that. And that is gonna be the gravitational force. Okay? What else? Mga palangga kung hitad. Okay? We have the molecular force. Okay? Molecular force. Mo na siya katong mga polar molecule, non-polar molecule. Okay, molecular forces. Okay? Ganon. Molecular forces can either be an intermolecular forces. Okay. This type of discussion, guys, is only good in if you have an examination that is, define, identify, explain, and then give at least enumeration, like that, and then outline. You have to outline, and then you'll be able to give an example after you will outline that one. Okay, something like that. But this is not good for multiple choice. Multiple choice is a little bit easy, right? Okay, so we have intermolecular forces and intramolecular forces. Okay, intra. Intramolecular forces are the forces of attraction or forces, repulsive forces between one compound in a single compound, whereas intermolecular forces is repulsive or attractive forces between two molecules or two compounds being considered between each other, acting like a bridge. For example, like water and another water, carbon monoxide and another carbon monoxide, like that. But within that carbon monoxide itself, that is intramolecular forces. Okay? But outside the compound to the other, that is intermolecular forces. Okay? The difference between intra and inter. Intranet and internet. Okay? Things like that. Same analogy. Okay? If you have an intranet, your intranet will not go to another building because it's only for this building. Okay, but the internet will go to another building like that because that is enter. Okay, like that. So muna siya enter and shop. Okay. So what else? The last one will be important. This is the this is gonna be the applied forces. Okay. Okay, the applied forces are the contact forces. Okay? Ganon. Okay. Like this. Okay. You got the point, mga palangga? Electric forces, mga palangga, is higher than nuclear forces. Ha? Okay, meaning the magnitude is higher than the nuclear forces. Applied forces, this is the famous forces we encounter in our daily lives. We need to push, we need to pull, we need to raise the object, we need to lower it, we have to stretch our hands, like that. Everything all about physical actions are applied forces. Okay, and this is what physics focusing well. Number 5 and number 3, and also a little bit of number 2. But the chemistry are focusing on number 1, number 2, and number 4. So we mean this relevant or major types of forces is a mixture of chemistry and physics forces. Get the point? Something like that. Now I'm gonna give you a sample problem, okay, with regards to electromagnetic forces and magnetic, flux, charot, magnetic flux density, charot, and magnetic field. Wow, grabe na kayo mga terms, God, no? Guys, no? So, grabe, okay? It's gonna be like that. Okay, because I really miss this kind of topics, guys, which, namungot ko ano when I was in college. Okay? Namungot yun. Okay? So I have here a problem, okay? That says a vertical wire. Saan siya? Okay. A vertical wire related to electricity, like a vertical wire. Okay, what's this? Wire of a current of related to electricity talaga siya, guys. A vertical wire with a current of saan siya? Of 40, what's this? 45 ampere? Yes. 45 ampere due south. See? The direction is considered 45 due south. Okay? So calculate the magnitude and direction. Nakakaloka. Calculate the magnitude and direction. Magnitude and direction. I will teach you something, so it looks like difficult, but this is very easy actually. Okay? And direction of magnetic field. Okay? Magnetic field, magnetic field 2 centimeter to the right. Okay? Field 2 centimeter To the right. Ganon. To the right daw. Okay. And then, what's the other one? Okay, muna na siya. Calculate the magnitude and direction of your magnetic field. Okay. Ganon. So in this kind of problem, guys, it looks like difficult, right? Especially if you are not really knowing the basic concepts of electromagnetism, like that, electrostatic forces, electric force, magnetic field, electric field. So it looks like difficult. For me, honestly, it looks like difficult. But you know, if you try to remember, so this is only articulation of the problem. Calculate the magnitude and direction of the magnetic field. Actually, this is just saying calculate the magnetic field. Okay? Or this is just saying calculate the magnetic flux density. Ganon. Okay, magnetic flux density. Magnetic flux density is just the same as magnetic field. Okay? You get the point? And the unit will just vary a little bit, but it has the same connotation. Okay? Connotation means it has the same concept. Okay? Something like that. Get the point? Now, klaro ka, yun na, gamit ka atong mga equation when relates to electromagnetic forces, di ba? Katong mga koan. Okay? Magnetic field, chuba-chuchuk na yun. Okay, ganan. So we have the our key terms here are magnetic field, in which we are trying to compute. Okay. Of course, the magnetic field have the magnitude and direction. Okay. Magnetic field, and then we have also the magnetic field strength. Okay. Magnetic field strength. How powerful or strong is your magnetic field in order for the electrons to flow or to move, to influence the movement of your electrons in your wire, something like that. Consider here, see, vertical wire. Okay? Magnetic field strength. Okay? Ganon. And then we have also the constants. Okay, of course, the Nicolopig constant. And this is now a little bit complex. Magnetic, okay? Magnetic field permittivity. Okay? Permittivity. Ganon. So magnetic permittivity, this is also called permittivity constant in free space. Okay? Permittivity constant in free space. Free space in your wire considered. Okay? The free space here, it would mean the vertical wire. And then, meaning the object you are considered with. Not all the time vertical wire. Because problems a lot, right? It could be another material, but in this sample problem is the vertical wire. As long as that is the free space in the particular object. Okay? You get the point? Ganon. So nanaka. Okay. Create a formula for this. Okay? So, magnetic field computation. Ganon. Okay. Based on my research, guys, because I did not encounter this in my college really. Okay, but you know, there's a little bit of discussion, but not really thoroughly discussed deeply. Okay, something like we have the magnetic field strength is denoted as H, and our magnetic field strength is H. Our magnetic field is capital letter B, and our magnetic permittivity is epsilon O, like this. Epsilon. Epsilon is a Greek term, denotes the E as in eagle, capital E, and you have to bow that to one. Okay? To curve. Okay? This one, curve. Just like M. You curve the M, and that is McDonald. And then in letter E, you curve sa nimo ang E, that is epsilon. Okay? You get the point? So if you try to compute the magnetic field strength, okay, it's gonna be magnetic field B over your magnetic permittivity constant EO is equals to H. Ganon. And now, since you know magnetic field density and magnetic field is just the same, so it's gonna be kilogram units. Very important, guys. Kilogram per second squared ampere. Ganon. Be careful. And this is equal to the basic unit of magnetic field and magnetic flux density is your Tesla. Okay. Okay, Tesla. So in the future generation, you will say, what is the unit of magnetic field? Hmm. Simple as that question. The answer will be Tesla, kalas. Okay? And then, this is Weber meter squared, per meter squared. So, ganun lang siya. For example, in this problem, it's given the Tesla, understood to use this unit during cancellation purposes. Because Tesla is very broad. It will be break down to kilograms per squares. A, ampere yan ha. And then, this is Weber over meter squared. Okay. Diba? You get the point? Mga kapatid. Okay, ganon. So, nanakain mga units sa imo, magnetic field density. How about your magnetic field strength? Nakaloka, strength. Okay, what are the units for this? Okay, your units will be like this. This is already complicated units, right? Nakakaloka. But sige lang. Okay? It's gonna be like Tesla, okay, ampere over meter. Ampere is current, right? Electricity. Tesla is magnetic field and meter is a distance covered, right? And we have also Newton, okay, ampere, meter. Okay, ganan. Okay, 2 units of your magnetic field strength. It depends on the problem what you're trying to use, then take down the units involved in your problem. Okay? Like that. And you can convert that one over the other, like that. And what is your magnetic permittivity constant? It's gonna be 4 pi, as I discussed this yesterday, times 10 to the negative 7. Okay, and this is farad meter. Okay, mga palangga. Okay? Muna yung value. Okay? So, imo yung timanan, guys. Then, if you try to break down this magnetic field strength into the more simplified unit, it's gonna be ampere over meter. Okay, simplified. Ampere over meter. And your magnetic permittivity constant is a farad per meter, and then it's gonna be the Tesla ampere over meter. Okay, ganon. You get the point? Constant is very important here, huh? Okay. You get the point, mga palangga ang bitad. Okay. Now, calculate na talaga siya. Okay. Actually, there's a long story of derivation by having experimental analysis for this. Our scientists in the past, especially the physicists, involve a lot of experimental analysis just to prove what are the formulas and equations to be used to, to confirm that the scientific research is to be valid, reliable, and accepted. Okay, it's not just as easy as it is. It needs to be proven so that it will be applied for everybody. So that's why they have to create the scientific research, because there will be a competition before. I think until now there's a Nobel Prize award if they can get that award. Something like that. Nobel Prize Award for scientific research about electromagnetism goes to ganon, Mr. Michael Faraday, of his study of electromagnetism, electricity, diamagnetism, like chuchu. Nobel Prize Award for example, the law of conservation of multiple proportion, ganon, given to a French chemist, Antoine Lavoisier. And he is now a father of modern chemistry. So before things like that have like that, so it's a competition, Nobel Prize in science. So that's why the units are coming from them. Most of the units in science are coming from the one who are discovering that particular topic. Okay? So that's why we have Newton, because Isaac Newton discovered that one. Ganon. Okay? You get the point? Wala siya. Now, calculate the magnitude and mupatamahuman, guys. Okay? Mupatamahuman. Okay? So, in the magnetic field that relates the circumferential, something like that. Okay, then you need to correlate in terms of the circumference. Something like that, okay? Why? So why you need to correlate the circumference? Because guys, the magnetic field is traveling in a circular surface. Of course, it will travel a circumference of 2 pi r. Get the point? Remember the circle? 2 pi r circumference, area pi r squared. cross-sectional area pi r squared, or it's gonna be pi d squared over 4, and then it's gonna be the circumferential area. It's another thing, right? It's gonna be 2 pi times d. If I'm not mistaken. Ano ba yun? Basta let's just circumferential area. Circumferential area is not the same with the cross-sectional area kasi eh. Okay? Something like that. As what I remembered in algebra. Correct me if I'm wrong, ha? Okay? That was too long, 20 years ago. That's only flashback in my brain cells now. Okay, something like that. You get the point? So, it's gonna be like, so after a long story of derivation, I don't have to derive everything. Okay, the time will be not enough. Okay, and maybe it's very complex also to consider. So they come up with a very simplified equation. It's gonna be like this: magnetic field, gonna chuba chu chu, is equal to the magnetic permittivity or permittivity na free space constant epsilon. Ganon. Okay, times the current over 2 pi r. Okay. So, nigamay na yun siya, ang equation. Ninindot siya ba? Simplify na yun. Okay, muna yung gamiton, guys. Okay? Because, nasa yung problem, because there's no density, there's no magnetic flux density, right? So, how can I apply there? So, and then I have the radius, see? Okay, 2 centimeter, or kayo, or distance. Okay? Like that, so, we have the magnetic field strength, ganon. Okay, the magnetic field, ganon, chuba-chucho. Okay. And then equal to your magnetic permittivity or the free space constant. Permittivity at free space. We have 4 pi times 10 to the negative 7, chuba-chucho, ganon. So, we're gonna use the ampere. Okay, now the ampere there, use the Tesla ampere. Okay, over meter and then ampere, right? Ganon. And then over 2 pi radius or distance covered 2 centimeter. Convert that to meters. It's gonna be 100. 1, 2, 3, 0.02 meter. Okay, 0.2 meter. So meter will be cancelled, I think so. Numerator and okay, wait, 1 meter divided by meter. So it's gonna be 1 meter times meter, hindi siya makancel, guys. Meter squared siya. Okay. Ganon. So, wala na siya yung answer. So, if you try to derive the equation, at least you will be able to come up with a unit of, ampere meter. Okay, because this is magnetic field strength. Okay. So, i-times mo, pila mo answer. If simplify mo, then we need to convert the units. This is now what we call Rumble units. So, we need to simplify. Okay? Rumble. Nag-rumble din siya. So, yung ampere here is 45 ampere. Substitute mo 45 ampere. Okay? Ganon. Okay, mga palangga. Okay. So, it's gonna be 4 times pi. Asa na itong pi, guys? Uy, nakalimut ko. Naman lang pi is shape pi. Okay? Exponent is equal to exponent negative 7 times 45. Okay. 4.5 times 10 to the negative 6. Okay, 4.5 times 10 to the negative 6. And then the other one also 2 pi. Okay. 2 pi. 0.0, so 2 times 3.1460 na lang kasi pareho na siya. Okay, times 0.02 is close to it. So 0.125664, 0.125664. So this is gonna be your magnetic field. Okay, like that. Okay, divided by 4.5 exponent to the negative 6 divided by 1.125666 equals to. You have 3.58 times 10 to the negative 5 magnetic field. Okay, 3.58 times 10 to the negative 5 magnetic field, meaning this is either Weber meter squared per meter squared or Tesla or kilogram squared ampere. Okay? Like that. Get the point? Okay. You can break that all over. Okay? Then you can, you can cancel that out. Okay? You get the point, mga palangga? It's gonna be like that. Okay? Okay. Any questions so far for that? Nothing? So, nothing, huh? Okay. So, if you try to break that, okay, for the purpose of further, further understanding, so because then it's very complicated, let's prove. Okay, wait, it becomes like that. Okay. Okay. Tesla, kilogram, squared, ampere. Di na pa kay ampere diri ari. Okay? Ampere, di ba? And meter pa jud siya. And ampere pa jud siya. Okay? Get the point? Kaya ano siya? Tesla times ampere. Ampere pa jud siya. Okay, so we need to say a squared. Cancel mo sa ka-a. So, mabili na niya a squared. So, it's gonna be kilogram a squared. Okay, like that na pa kay meter. Ganan. Meter over meter. Kasama mo siya. So, kilogram a squared meter. Meter 1 meter squared. So, meter squared. Ano siya? Kilogram a squared meter squared. Okay. Ano siya yung mabilin? Kilogram a squared meter squared. Meters, it's gonna be weight. Okay. Kilogram a squared meter squared. Ganon. Since meter squared is area, bingo. This is your magnetic field. Di ba perfect? Ganon. See? Niyanak mo po guys naman. Kilogram area second squared over meter squared. This is the same as kilogram a second squared times m 1 over m squared. It's gonna be kilogram a squared, okay, m squared. Since m squared is the area, it's the same. Kilogram a squared area is the unit of magnetic field. Perfect. So we can derive really. That's correct. Okay? So just remember that it's gonna be like a Tesla is a kilogram second squared ampere. Ganon. Daog na yun. Do not use the Weber meter squared, because it's another thing. Okay? Because the Weber, you need to focus on the farad. Okay? Like that. So, farad will be more complicated for this. Okay? Farad. Okay? A magnetic field strength is the ampere per meter. Okay? Ampere per meter specified. Okay? You get the point? Ganon. So, makuha rin mo siya guys. Ano siya pang answer? 3.58 times 10 to the negative 5. But that is still our magnitude. Okay? For our magnetic field. Or magnetic flux density. And then the direction. How can we do the direction? Okay. Let's draw na. Let's sketch. Because you asked of the problem, both the magnitude and direction man siya. Okay, it's gonna be like that. So it's gonna be the wire, vertical wire. Okay, then a current of 45A. So south, due south daw. South, north, east, west. Okay, so this is gonna be south man siya. So it's gonna be, I think, directly downward, right? So it's gonna be directly downward. So your magnetic field will go to the left. Okay. Enter to your page here, ganon, and okay, go away from your page here, like that. Okay, it's gonna be your magnetic field. Okay, so your direction of your magnetic field is away from the space considered. Away, see? Ganon, like that. So padulong siya dito, circular motion going to the right. So we need to say going to the west. Okay. Going to the right. Okay. We are not sure really where is the S and where is the west. As long as we have the right here, left here, okay? So it's going to the right. May arrow, see? Ganon. Going to the right. Okay, and going to the right. Okay, this tuyok siya. Okay? Going to the right and away to the left. Okay. Ano siya, oh? Ano guys, Tararat, 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 tararat. Ganon. Okay? So, that's your magnetic field. Basta magnetic field ganun guys, circular good siya ha. Okay? Ang direction. Okay. So, to further understand also, did you understand guys? Thank you so much for watching. Okay. You can comment down below in the comment section. You can share the video if you want also. And you are not subscribing my YT channel, then you can subscribe and hit the notification bell for some news updates on my singer, Eternal Voice. Bye bye. God bless everybody. I may discuss about tomorrow because you know, sakit akong tiil. Char! Nakakalawa ka sakit daw. Okay. I may discuss the relation of magnetic force and magnetic field, why it is circular. Okay? And then we can create the centripetal force, ganun, chuba-chuchu, di ba? Thank you so much. God bless everybody.